In this video, we're going to talk about how to use the lpsolve package in R to optimize a daily fantasy showdown draft. My name is Tim Mattis. I'm going to present this here just for educational purposes. Okay, so actually betting money in a daily fantasy draft is really not a good idea. There's a the company offering the draft generally takes like a rake of 10 or 15%. So it's not a good idea to do this for money purposes, but it can be a lot of fun if you have a league and if you have other friends, that you're playing with. Sometimes you'll want to find a good draft and maybe try to beat your friends. So I just present this here for entertainment purposes only, and also a way to learn how to use R in a context that you think might be fun. So the first thing is, what is a daily fantasy showdown? Well, this is a fantasy roster or a type of fantasy game which is created for a single game between two teams, right? So it's only one single game, two teams. One player is going to be chosen as a captain, and five other players are going to be chosen as utility players, and these players may come from either team. Each player that's going to be drafted onto a team has a cost or a salary that has to be paid, and the total salary of the entire roster or lineup must be less than 50,000. If a player is drafted as a captain, then their salary may be greater than if they were drafted as a utility player, right? So why would you want to draft a person as a captain? Well, we get to that here in 1 second. As the game is played, players are given points based on their performance. For example, you'll get points for shooting a basket, maybe points for blocking a shot, making an assist, etc. And the captain score is going to be multiplied by 1.5, right? So there's a multiplier. So there's an advantage for a player being a captain. And the winner is going to be the person whose drafted lineup has the greatest score at the end of the game, right? So if you're playing against your friends, if you have the greatest score, then you win, right? Okay, so what's the problem? Well, succinctly, the problem is to find a lineup that maximizes the expected number of points scored by the one captain and five utility players such that their salary is less than 50,000, right? In one statement, that's what we're trying to do. Now, for those of you who've maybe had some mathematical programming experience, you may start thinking, hey, well, maybe I can look at this as a optimization problem, and I want to maximize a function where that function is going to be the expected number of points that's scored by the lineups, subject to the following constraints: that I have to have one captain, five utility players, that their salary must be less than 50,000, and that a player cannot be both a captain and a utility player, right? They can be either one of those or none of them, but they can't be both. Okay. Going a little bit more deeper into the math, you can say, oh, well, this is really just a constrained optimization problem. And it's a constrained optimization of this form where we're maximizing an objective function subject to these constraints, where this x is what's called a decision variable, right? And the x is going to ultimately be zeros and ones. And a zero is going to say that we do not put that player in that position, where a one would mean we'd select that player in that role as a captain or utility player in the final lineup, right? So at the end of the day, we're going to be really looking at these zeros and ones, and we're going to have six of them, right? We're going to have six, at the end of this mathematical program, we're going to have 6 ones, and what those are is going to tell us what our lineup is going to be. So let's go ahead and connect this problem to the data, okay? When you're getting the data from, let's say, DraftKings or something like that, it's going to look something like this. Now you're going to have some extra columns in here, and you can just get rid of those columns because they're not necessary. But you can see here we're going to have the players from the two different teams, and we're going to have them listed both as being a captain and as being a utility player. There's going to be 18 players in this example that we're doing here. There's 18 players on each team for a total of 36 players. But since we also have them as a captain and utility, there's actually 36 times 2, or 72 rows, right? So there's going to be 17 rows in this example data set that we're going to be looking at in this presentation. You can see here, let's look at Alex Caruso, who's a player for the Los Angeles Lakers. I think he went to Texas A&M too, where I went to school at. But his salary, if he were just a utility player, would be $4,400. And his average number of points that he scored in the previous games is 13.37. Okay. If we were to make him a captain, well, his salary now is 6,600, but the average number of points is going to be this 13.37 times 1.5, which is going to be the 20.06, right? So he costs more, but he gives us, more points towards the total. And this, again, this column is just the average points per game based on the previous games that these players have played, right? And you can see here, let's look at Austin Rivers. So Austin Rivers, he plays for Houston. If he were a utility player, his salary would be 1,400 and his average points per game is 15.97, right? Where if we were to make him a captain, now his salary would be 2,100 and his average points per game would be 23.69. Now, if you're following this, you're maybe saying, hey, wait a minute, there's something that seems a little bit strange here, because Austin Rivers, his average points in the previous games is 15.97, but which is more than that for Alex Caruso, but he costs a lot less than Alex Caruso does. So why is that? And the answer to that is I don't really know, right? It's obviously there's not a linear relationship between the salary and the average number of points per game. Maybe there are other factors which are coming in here, right? To how the DraftKings or Fantasy Draft or whoever, how they set this salary. So I'm not exactly sure how they determine what this salary is going to be, but it is what it is, right? They determine what this is, and this is what you have to work with. And again, the average points per game, that's going to be the output that we're looking at in this video. Now, obviously, too, there may be other factors to consider here besides just the average number of points per game that you maybe want to consider in your draft lineup. For example, opponent rank, right? What's the rank of the opponent that they're playing against? What is the, does this player, for whatever reason, play poorly? Do the Lakers play poorly against Houston, right? There are other factors which don't come into this because our only objective is to maximize the expected number of points per game using the average points per game in previous games to be that coefficient, right? That we're looking at in that function, in that maximization function. So anyway, that's the data that we have here, and hopefully you understand what the data looks like. So now we need to take that data and we need to connect it to the problem, right? Here's the problem that we have, or here's the linear program that we have, and here's the data. So how do we take this and match it up with this? Well, the first thing is, let's take a look at this C, right? And we talked about that. The expected number of points per game, we're going to say that's going to be the average number of points per game. And remember, ultimately, when we're done with this program, after we've run it through R and it's done the simplex method and all that, this X is going to be zeros and ones. And if it's a 1, then it's going to sum. If it's a 0, then it's not. So we want the sum of this to be as large as possible, right? So we're going to use this column for C in this program. Now, what about for the constraints? Well, we have salary. Remember, salary needs to be less than 50,000. And we also have that there can only be one captain and one utility player. But the way that this is structured, this is non-numeric, and this is hard for R to read, right? We want our data to be tidy, and we want these to be numbers and not variables. So we're going to create two new columns, a captain column and a utility column. And it's going to be 1 if the position is a captain, and a 0 otherwise, or it'll be 1 if utility in the utility column, or a 0 otherwise, right? So it's just going to be, we're going to have 36 ones here, 36 zeros, 36 zeros, and then 36 ones, right? So we've taken this column here and we've represented it now as two numeric columns. Perfect. So now we have part of A, right? We have the salary, we have captain, and we have utility. So we have those three things taken care of. But remember, we have the additional constraint that a player cannot be both. He can either be a captain or a utility player, but he cannot be a captain and a utility player, right? So for that, we're going to have to create some more columns. And we're going to create 36 of them, right? 36 players. We're going to create 36 more columns. Where in this column, each column is going to be dedicated to a single player. So column 1 is going to be the Alex Caruso column. And we're going to put a 1 in those rows in which Alex Caruso is represented and a 0 otherwise. So he's going to have a 1 if he's a captain and a 1 if he's a utility player, right? The next column we're going to have for Anthony Davis, a 1 if he's a captain, a 1 if he's a utility player, and 0 otherwise, right? 36 of them because there's 36 players. And so that's going to give us now this full matrix of A. And as you can see, there's 36 players. And then there's 36, 37, 38, or I'm sorry, there's 72 rows actually, right? Because we have the captain and the utility. So there's 72 rows. And then we're going to have 36 columns here, but then that 1, 2, 3. So we're going to have 39 columns, and we're going to have 72 rows in this A matrix. Okay. Finally, we need to get the right-hand side for this. So the right-hand side, we say, okay, well, this salary, remember, we want this to be less than or equal to B. The sum of these salaries must be less than or equal to 50,000. The sum of the captain must be less than or equal to 1. The sum of utilities must be less than or equal to 5. And then again, when we look at each player, we can look at Caruso here, for example, in column 1, and we can say, okay, well, he can either be a captain or utility player, but not both. And so when we sum this up, it's going to have to be less than or equal to 1. If it was 0, then that would mean he's none of them, but less than or equal to 1. So this is going to set the upper bound on the, or it's going to set the right-hand side on this constraint matrix. All right, so now that we have that, the only thing that's left to do is to put this all into R and then run that lpsolve package. So again, we have 72 different columns, or I'm sorry, we have 39 columns and we have 72 rows. The C, which that's going to be the average number of points per game. B, that's going to be that row which we had that denotes the right-hand side. The sign, we're going to need to create a vector which is going to have all these less than or equal to's. And then A, that's going to be, we're going to pick out those columns that correspond to the A matrix, right? So if you look back at here, you can say, I'm going to take this here, and I'm just going to pick those elements out, and I'm going to write them into R as either vectors or as a matrix, right? And then in the lpsolve package, we have this one command, which is lp, and this is where you could say the magic happens. We run this lp command. We want to maximize, and then we have C, which is going to be our vector of those coefficients of the decision variables in the objective function. We have A, which is going to be our constraint matrix, the sign, the B, which is going to be the right-hand side. We want transpose constraints. We need to set this equal to false, right? It's going to say true. It's going to default to true, but we need to set it to false because we already have the constraints in columns and the decision variables in rows, right? So be sure to set that equal to false. And then all bin is equal to true means all binary, which means all of these, the decision variables are going to be binary, right? All right, so thank you for watching this part. We're now going to start the part where we talk about how to do this in R. So now let's show how to do this in R. Well, the first thing that you're going to want to do, if you haven't already done so, is install the package lpsolve, right? So I have that here. I've commented out the line because I've already installed it, but you're going to need to install that package. You also are going to need to install the package dplyr, similar to how you would install the lpsolve. I've already got those, so again, I'm not going to reinstall them, but I'm going to load those packages in because both of those we're going to use in this example. Now, for me, I generally set the working directory for my files, and so that way I can just go in there and load the file directly, right? So I put this file DK salaries 3 into this downloads folder. If you don't know how to do that, then another way you could do this is you could type like dat and then read.csv, and it's CSV because it's a CSV file, right? Which the file that I downloaded from DraftKings was a CSV file. So we're going to read that in. You could also do file.choose and then go like this, and then that'll give you more of this interface that you're probably used to seeing to load in your file, right? But I'm not going to do that. I'm just going to read it in directly, which we've already done. And then the next thing we need to do is get this in shape. So let's look at this file, right? This is what I get from DraftKings. I get all these columns: position, name, ID, roster position, salary, game info, team abbreviation, and the average points per game. I want to get rid of some of these columns because I don't really need them. But remember, I need to make that column for whether or not the player is a captain or utility player, that column of zeros and ones, plus I need to make a column for each player, right? I have to make that column for each player where it's going to be a 1 if that player is a captain and utility player, and 0 otherwise. So I'd have a little bit of work to do to get this into shape. And you can see that I do that here. The first thing is I'm going to get rid of the columns I don't want. I'm going to take, if it's a captain in the roster position, I'm going to create a 1 and a 0 column, which I'm going to call captain. I'm going to create a column called UTIL, which is going to be 1 if it's a utility player, 0 otherwise in that roster position column. And then finally, I'm going to create a points per game, which is going to multiply the average points per game of the player by 1.5 if it's a captain, or it's just going to put the points per game as being what it is otherwise if it's a utility player. And then I'm going to sort it by roster, position, and name. Okay, so when I do that, now if I look at my data file, you can see I've cleaned it up a little bit. I still have the ID in there, which that's no big deal. We'll just drop that out later. But you can see now I have this column of the ones and the zeros, and then I also have the points per game, right? So I've shaped this up a little bit. I still don't have that A matrix. I still don't have those columns on here for each player being a 1 and a 0, but I'll get that here in 1 second, right? So we've made it look a little bit better. Right now I'm going to build that identity matrix, which is going to give me those that rows of that rest the A matrix. And now I'm going to bind it to it. And so if you look at it again, now we have it, right? So here we can see this would be for Alex Caruso, say, right? He has a 1 if he's a captain. And then when I come down here, I should find another 1 here for Alex Caruso. Yep, if he is a utility player, right? So there's Alex Caruso as a utility player. So it's a 1 for a utility player, 1 for captain, 0 otherwise. And then the next one's for Anthony Davis and Austin Rivers. So again, you can see this repeating diagonal of 1s, which goes all the way down. And then it's going to start over at row 37. And you should then again see this repeating diagonal of 1s going down, right? So now we've got it just like we had it in the file shown previously. And now we can actually do the LP, right? So in the file objective, I actually put a C. So I called this C, but here I'm calling it OBJ or objective. You could also call it C. I want to create that A matrix, which means I'm going to need to drop out some of these other columns. And when I do that, I get the A matrix, which now looks like this, exactly like we had it. The salary, captain, utility, and then all of these columns of 1s and 0s, right? So now I've got the A matrix. I need to create, remember, I need to create that sign vector with the less than or equal to's. So I'm going to do that. And you can see as it pops up over here, I have 39 of them because I have 39 constraints, all the less than or equal to's. The right-hand side, I'm going to have the 50,000, which is going to be for the salary, the 1, which is the number of captains, the 5, which is the number of utility players, and then a 1 for each one of those other columns, which denotes again that there can only be a player can either be a captain or utility or neither, right? All right, so now we've got it all, right, as we've talked about. This right-hand side also I called a B. So I called objective C and I called right-hand side a B. But now we can run the magic. We can put it in here into this LP command and run it. And hey, it says the objective function is 261.39, so it's success. It's found a optimum solution, and this is going to be 261.39 is the maximum amount of points that you can get. There, in other words, there's no other lineup, unless there's a dual optimum, but there's no other lineup which is going to give me more than 261.31 expected number of points, right? It's the maximum expected number of points that I can get. I'm going to take and I'm going to read that into an object called ID, and I'm just going to pull out the solution. And then when I do that, I'm going to bind that onto this data file, and then I'm just going to pick out those rows in which the optimum is equal to 1, and then I'm going to select what I want to see from that, and I'm going to read that into a new file called dat2, and here we go, right? So here is my optimum solution. This is that solution which gave me the 261.39. I have Rajon Rondo being as a captain. His salary as a captain was $1,500. There's the average number of points per game. Then Anthony Davis, Avery Bradley, James Harden, LeBron James, and Russell Westbrook. So this would be my lineup, okay? And again, this lineup maximizes the expected number of points per game. It doesn't take into account other variables which could be there, such as, for example, opponent rank or things like that. There may be reasons why you don't want this lineup, but there is no other lineup which is going to give you a better expected return. Or that's going to do better at maximizing that function of the expected number of points per game. But let's say, for example, we're going through here and, oh, it turns out we're trying to put this in, but it turns out that Anthony Davis isn't playing tonight, right? For whatever reason, maybe he's hurt or otherwise, or maybe we just don't want Anthony Davis in. Maybe we look at that and say, yeah, Anthony Davis doesn't play very well against the Houston Rockets for whatever reason. He doesn't like going up against their center. So, we want to take him out and run it again. How do we do that? Well, we're just going to filter that out, and we're going to put that name in the exclamation point means exclude, right? So we're going to exclude Anthony Davis from the data set, and that gets rid of him. And then we're going to run this again, right? It says rerun LP. So we're going to take, and I'm going to highlight this, and I'm just going to run it all as one block this time. And now my new objective function is 257.37, right? So the best that I can do without Anthony Davis, or the expected number of points, would be 257.37. Now I would draft James Harden into the captain role, and I would have Dwight Howard, Eric Gordon, LeBron James, Rajon Rondo, and Russell Westbrook. So you can see now Anthony Davis is gone from here because Anthony Davis now has been removed from the data file, right? You can see it's now gone from 72 down to 70, right? And then you can just keep playing with this. You could say, oh, well, maybe I don't want LeBron James for whatever reason. So you could filter out LeBron James and then run it again. So you could iteratively go through and find some roster that you like. So anyway, thank you for your attention to this video. I'm going to have the PowerPoint slides, the data file, and this R file in the comments there. So you should be able to download those and play with this if you want. All right, appreciate your attention. Thanks.